to increase the flow of the system, we can use some pumps parallel to work. If the pumps work in parallel, we have got some conclusion. For same pump in parallel, we usually can met this is one pump's curve. It's flow. If two of them work, the flow was added to A, but the head is different. Is not changed. Cannot change. It's a idle condition. We can get this. And we have known the two-stem characteristic pump in parallel has best performance when it operation. And if we change the pump speed, two-stem pump in parallel with varying speed synchronously has the best performance also. So according to the analysis above, we can result in the regulation range of the power corresponding to 20% speed variation is about 50%. This is come from the function of P and N. And the efficiency of pump change in a small range corresponding to in this range of the speed variation range, its efficiency usually high. For designing such a system, the largest challenge in the wind-driven pumping system is whether or not the power regulating range of pumps may cover the fluctuation range of wind energy from the given head lift and higher efficiency. So for this arm, we can draw out some point for design. The characteristic of the pump and the pipes have a flat HQ curve. We need to have such a characteristic because this will result in small high change when the liquid is variation. The two is the rotational speed regulating range is between 80% to 100%, this area. The operation power relative this range is about 50% to 100% of N. And in this area, we can keep the efficiency of the pump around the rated value. And the operation mode of the pump system have two different ways. One is one variable speed pump operates, or two variable speed pumps operate synchronously. we can design the system along following steps. First, we need to determine the capacity of the wind farm. We need this wind farm must to consider two conditions. One is the reservoir capacity, and another is the transform efficiency of a wind pump system, and to determine the wind farm. And then to determine the available maximum power, wind power, and the minimum wind power. Then choose two pumps. The 3, 1 is for spare. So 2 pumps with rated power at half maximum power. And these 2 power will work at a range of fluctuating wind cover a part of fluctuating of wind power. And we also need to choose another 2 pumps with rated power of 1 at maximum power. Such the operation mode and this condition, we have one variable speed operation, 1 pump, a variable speed of operation. Its speed varying range is 80% and to 100%. And the 2 variable speed operations synchronously in parallel operation, they will can cover 1/4 to 1 such pump. And another pump operation mode is cover at this area. For the power rest can be designed by the step as above if necessary. You can see an example. Let us assume the wind farm capacity is 1.5 megawatts, and choose 2 pumps with rated power 750 kilowatts, and another 2 pumps with rated power 188 kilowatts. Then, when the wind power vary between this area, the number 4 pumps speed varying between this area. Let's see the picture. If this wind power curve, and this number 4 pump variable speed operation at this area. And this area is 2 pumps synchronously operation. And this one is large pump, 1 large pump, variable speed operation. And in this area is 2 large pump, variable speed synchronously operation. So such we can cover all of the fluctuating area of all the wind power. Okay. The electrical configuration of the pump storage system, we can divide into two situations. If the wind farm is far from the pump station, we can use AC connected network. Each pump controlled or driven by a converter, and if the wind farm is located close to the pump station, we can use multiple DC network like this. This connection is it has better economic, smaller volume, and control flexible. Discussion. Operation efficiency of pump and the cost performance of the system is the one problem in this system. The design of the pump should have a wide speed regulating range and under a given head lift variation range. And how to increase the operation efficiency is a challenge. And another is a proper compilation of the pump groups needs a systematic analysis to the cost and the performance of a whole system. And two is the parallel problem for multiple standalone wind turbine if the AC system is used for transmission. Because it's a standalone system, so the wind turbine, we think it is to start up a turbine in a passive inversion mode. And the rest of the turbine are start up in the active inversion mode and interconnected to each other in an orientation fashion, such to solve the parallel problem. And if a DC system is used for transmission, it's critical to have a proper DC circuit breaker. The wind turbine needs to be customized. These two problems exist in the DC connection systems. Conclusion. In an isolated system of wind turbine and pumps, to ensure the stable operation of the system, it's crucial to have the regulating capacity of the pump to cover the variation range of the wind energy. One way to check the wind energy variation through the speed control of the several groups of pumps. The DC or AC transmission will be chosen according to the distance of the transmission. And a design method of pump system is presented in the presentation. But more detailed research managed by simulation must be needed for the design of the system parameters. The evaluation of the system performance and the optimum design. Thank you for your attention.